Good day! Today, we're going to continue discussing operations on functions. But this time, we're going to focus on multiplication of functions. So first, let us try to define what is multiplication of functions. When given two functions, say f of x and g of x, their product denoted by f that g of x is the function defined by f that g of x is equal to f of x that g of x. By the definition of the product of two functions, we just multiply the two given expressions for f of x and g of x. To further understand the definition, let's try to have some examples. Our first example is, given the functions f of x is equal to x squared and g of x is equal to 5x plus 2, let us find f dot g of x. Okay, so we're going to perform it step by step. So first, we're going to write our working equation. That is f dot g of x is equal to f of x dot g of x, or f of x times g of x. And then the next step would be substituting the functions f of x and g of x. Doing that, we're going to have f that g of x is equal to x squared times 5x plus 2. Okay, that's our second step. Our third step is we're going to apply distributive property of multiplication. So meaning to say, we're going to distribute x squared to 5x plus 2. Doing that, we'll have x squared multiplied to 5x plus x squared multiplied by 2. Okay. After that, we're going to simplify it further. So x squared times 5x, that is equal to 5x cubed. Five x cubed. And then x squared times 2, that is equal to 2x squared. Therefore, our final answer is f that g of x is equal to 5x cubed plus 2x squared. Okay, now let's try to have the second example. Our second example is, what is f that g of x if f of x is equal to 5x plus 2 and g of x is equal to 8 plus 6x minus 2x squared. Okay, so once again, we're going to do it step by step. So first, let us try to write our working equation. So that is f that g of x is equal to f of x times, or that, g of x. And then after that, just like in our previous example, we're going to substitute the values of f of x and g of x. Doing that, we'll have 5x plus 2 dot 8 plus 6x minus 2x squared. Okay, so after that, we're going to apply the distributive property of multiplication. So this time, we're going to distribute 5x to each and every term of g of x as well as 2. Okay, so let's try to do it. That is 5x times 8 plus 5x times 6x minus 5x times 2x squared. Okay, and then plus 2 times 8 plus 2 times 6x minus 2 times 2x squared. Okay? Then after that, we're going to simplify further. Okay? So doing that, we'll have five x times 8. That's 40x plus 5x multiplied by 6x. That's 30x squared. And then minus 5x times 2x squared. That's 10x to the third. Then plus, that's now going to perform the second part. 2 times 8, that is equal to 16, plus 2 times 6x, that is equal to 12x. And then minus 2 times 2x squared, that is 4x squared. So after that, we need to combine like terms. And then while combining like terms, let us try to express or write our answer from highest degree to lowest degree, or uh, their exponent is in descending order for the uniformity of our answer. Doing that, we'll have, so first, let's try to look what is the highest degree of our exponent, and that is the third degree, or the exponent 3. So negative 10x cubed, and then 30x squared subtracted by 4x squared. So we'll have plus 26x squared. And then 40x plus 12x, that's plus 52x. And then lastly, we're going to write the constant, which is plus 16. Therefore, our final answer is f that g of x is equal to negative 10x cubed plus 26x squared plus 52x plus 16. Okay, let's have another example. This time, what is f that g of 2 if f of x is equal to 6 minus 2x and g of x is equal to 4x minus 3. So once again, we're going to do it step by step. So just like in our previous example, let us first try to have the working equation. That is f dot g of x is equal to f of x times or dot g of x. And then after that, we're going to perform substitution. That is 6 minus 2x times 4x minus 3. So take note, there are some of our examples given that I omitted the multiplication or operation or the dot symbol. But that is okay because omitting it will also mean that we're going to perform multiplication. And then next, we're going to perform distributive property of multiplication. So we'll have 6 times 4x and then less 6 times 3 plus negative 2x times 4x then less 2x times negative 3. After that, we are now ready to simplify it further. Doing that, we'll have 6 times 4x is 24x minus 6 times 3 is 18. Then plus negative 2x times 4x, that is negative 8x squared. And then negative 2x times negative 3, that's positive 6x. Simplifying it further, we'll have negative 8x squared plus 24x plus 6x, that is 30x. And then lastly, our constant, which is negative 18. So our final answer would be f that g of x is equal to negative 8x squared plus 30x minus. Now, we are ready to substitute our solve function by 2. Doing that, we'll have negative 8 times, substituting the value of x by 2, we'll have 2 squared, and then plus 30 times 2 minus 18. Simplifying further, we'll have negative 8 times 4 plus 30 times 2 is 60 minus 18. Then we'll have negative 32 plus negative 32 plus 60 minus 18. So our last step is to get their sum. Negative 32 and negative 18, that is equal to negative 50 added to 60. Our final answer would be equal to 10. Therefore, our answer is f that g of x is equal to positive 10 or 10. Now, let's try to have some examples, this time involving some fractions. So our problem is find f that g of x given f of x is equal to x plus 7 over x plus 1 and g of x is equal to x minus 2 all over x plus 3. Okay, so once again, we're going to have the first step, that is by writing our working equation. Doing that, we'll have f that g of x is equal to f of x dot g of x or times g of x. Then after that, we're going to perform substitution. So we'll have f of x as x plus 7 over x plus 1 multiplied to another fraction, which is x minus 2 over x plus 3. Doing that, we're going to have x plus 7 multiplied to x minus 2. And then for the denominator, we'll have x plus 1 multiplied to x plus 3. You're going to notice that if we're going to multiply two expressions that are fractions, we are just going to multiply numerator by numerator and denominator by denominator. Or we multiplied the numerator of f of x to the numerator of g of x, and then we multiplied the denominator of f of x to the denominator of g of x. The next step is simplifying the numerator and then the denominator. So we'll have x times x and then minus or plus x times negative 2 plus 7 times x plus 7 times negative 2. For the denominator, we'll have x times x plus x times 3 plus 1 times x plus 1 times 3. Okay? So next step is we're going to simplify the numerator and the denominator of our last step. That is x squared or x times x that is equal to x squared and then x times negative 2 that is negative 2x plus 7x that's plus 5x and then lastly the constant 7 times negative 2 that's negative 14. For the denominator, we're going to have x times x and that is x squared and then x times 3 that's 3x plus 1 times x that's x, so we'll have 4x and then the constant which is plus 1 times 3 is 3. So since there are no way that we can cancel out an expression from the numerator and then the denominator, then our answer is this one. F that g of x is equal to x squared plus 5x minus 14 all over x squared plus 4x plus 3. Okay? So this time, we're going to have A worded problem. A farmer has a rectangular plot of land, and the length of the plot of land can be expressed as a function L of x, which is equal to x plus 2 meters. And its width can be expressed as W of x is equal to 3x plus 21. Find the area of the plot. Okay, so we have a worded problem here, but then you're going to notice that the steps that will be involved in solving the area is length times width. And it so happened that if we're going to multiply the length, which is L of x, and then the width, which is W of x, we are performing multiplication of functions. Okay. So let's try to perform it. Once again, we're going to insert our working equation. So that is L dot W of x. So L of x stands for the length, and then W of x stands for the width. So that can be rewritten as L of x multiplied to W of x. Okay? And then we're going to substitute the given. That is x plus 2 multiplied to 3x plus 21. Then we're going to apply the distributive property. We'll have x times 3x plus x times 21 plus 2 times 3x plus 2 times 21. Simplifying further, we'll have x times 3x, that is 3x squared, then plus x times 21 is 21x plus x, or 2 times 3x, I should say, that's 6x plus 2 times 21 is 42. And then we're going to combine similar terms. So we'll have 21x plus 6x, that is 27x. So therefore, our final answer is L that W of x is equal to 3x squared plus 27x plus 42. Therefore, the area of the rectangular plot of land is equal to 3x squared plus 27x plus 42 square meters.